Okay, 5.3 is transformations of sine and cosine. This is all stuff we know, but we just got to apply it to sinusoidal functions now, like sine and cos. All these letters mean the same thing. We're just going to handle them a little bit differently because if you kind of think of them the same way as chapter 2 and 3 when we had the transformations of like exponentials and all the other functions, it's harder to graph. So if you follow my rule of thumb, graphing sine and cos is a breeze. It's actually fun. And I'm going to show you what all these things mean. So the A value, while it used to mean our vertical stretch and compression, it still means that. But if I have my center axis, the amplitude is going to be how far up and how far down the function goes, right? That's the amplitude. It's half the distance between the max and the min. So because we know it's half the distance between the max and the min, we find the distance between max and min, distance is just subtraction, and we divide it by 2. And that's a formula for amplitude. Because generally speaking, in even word problems, we can figure out what the maximum and the minimum are. And if we know those two values, we know the A value very easily. Okay, so we prefer this to find A. I'm going to talk about C right now because they are the Y values and they're the first things that we attack when we graph. The C value is the center axis. It's where the center of the sinusoidal function is. So if I know the max and the min, to find the center is just midpoint. So to find the midpoint, I just do max plus min divided by 2, and that's my C value. So just by knowing max and min, I now know two numbers in an equation, right? This could be sine or cos. You can figure that out at a later time. But we've just attacked two letters, and we've solved them pretty easily. Now, K used to be kind of a pain in other functions because it's horizontal compression, and we don't want to really deal with that. But luckily, it's different in trig. It's not really different. It's still a horizontal compression or a stretch, but we have to understand it using the period. Because we're doing periodic functions, this is going to tell me how many cycles are going to occur between 0 and 360. Okay? You might not need to understand this. So if this was 360 and k was 4, I'm going to have 4 cycles between 0 and 360, which means that a period is a fourth of that. So we use this to understand the length of a period. If I can figure out what the length of a period is, I can find the k value and just plug it in. If the period is 2, k is 360 divided by 2, k is 180, boom, done. K is very easy. Just a note here, we could also find, use a different color, we can reverse these, right? If I don't know what the period is, I could just find it using the k value. Let's say I have an equation, right? I need to know what the period is to graph. I need the period, it's the first thing I need. Okay, so I can rearrange these. Both these equations are true. Now I box these equations because you should have them handy at all times, memorize them, because they are so clutch that this becomes so easy once you just know how to find the letters. Now D, different story. You really have to understand trig to find the D value because this is where we're going to start the function. You could find it algebraically, but that's a disaster. I can show you that at a later time. But we need to know where to start the function, and that's the phase shift. So if I know cos starts, up here and it's shifted to the right, I just start it to the right. But you have to know how cosine starts, which we do from 5.2, right? Cosine starts at the maximum. So now we're going to go through some examples, and I'm really going to focus on the importance of your scale. Okay, so take a look at this question. I have to graph y equals 3 sine of 4x. And I have to graph it from 0 to 360. We need to pay attention to where to graph it from because that changes. I can graph it from 0 to 360, 0 to 720. The question can just say graph 2 cycles, graph 3 cycles, whatever the case may be. So let's outline our letters. This is my k value, and this is my a value. My C value and my D value are 0. So because my C value is 0, I know the center is going to be the x-axis because it's not shifted up or shifted down. I should have explained that in the previous slide too, where that shifts the thing up and down. So I know that the center is over here, and I know that it's going to bounce 3 up and 3 down. Very important. So to know where it's going to bounce, I always draw a dotted line at my max once I know my max. That's at 3. And at -3, I draw a dotted line. Every single time. I also draw a dotted line on my C value. But because it's 0, there's already a line there. I don't have to draw a dotted line over. And the reason why I draw a dotted line is because in trig, I have to graph like this way. And sometimes I have to keep going pretty far. And I don't want to keep looking over here, trying to line up am I on the right spot? Sometimes I graph it one below. It's annoying, right? So if you just draw a dotted line, you know you always have to graph there, on here, or on here. There's nowhere else you graph in trig that is not on one of these three lines. The center line, the max line, the min line. That's how it's so easy, because you only have to graph on these lines. So everything is almost taken care of except my x-axis. Max attention right now to scale my x-axis. X-axis scale. It is always a period divided by 4, and I'll tell you why. There's 4 key points in trig. There is the terminal arm moving over here. I don't care about all of these angles, right? We care about horizontals and verticals. Horizontals and verticals. Horizontals, these are easy. So in one period, I have 1, 2, 3, 4 key points that I care about. And those are going to be the max and mins. So if I divide the period by 4, that's the scale that I have to use to separate those 4 points. So first I have to find the period. Yes. I go here. The period equals 360 over k. The period is 90. Now that I know the period is 90, my scale is going to be 90 over 4, 22.5. Is that a pain in the ass? Yes. I'm not going to write down 22.5. It's 4 characters. Never in my life will I choose to write down 4 characters if I don't have to. But what I'm going to do is I'm going to leave a box for half of my 45. So take a look at that. That's 22.5. I don't have to write 22.5. That's going to make it look ugly. So I'm just going to write a multiple of 45 after each second box. There's another 22.5. See how much easier it is? And just keep doing this. So that's 45. That's 90. This is 135. This is 180. And I have to go to 360, so I have to keep going. Plus 45 is 225. Plus 45 is 30 instead of 270. Obviously, the down. I'm going to run out of space now. I'm a fool. Plus 45 is 305, and then 360. Horrible, but I made it work. So I scaled it in 22.5. And again, when I say scale, I mean on your grid paper, a box should be this. At most. You can make it even smaller, but this is the minimum value that it can be. So I scaled it in 22.5, but I just multiplied by 45 because I don't want to get my calculator plus 22.5 plus 22.5. Gross. It was already annoying adding 45. Okay, so we've scaled. We've done all of the work. The rest is we have to figure out where sine starts. We should know where sine starts. It starts at the origin. Now, if there was a d value that shifts it to the right or the left, my starting point just needs to shift to the right or left. That's the only thing that d value does, shift the starting point. And now, because my scale factor is 22.5, every 22.5, or every box in my grid paper, has to be the next point on this trig function. And remember, well, I didn't make a video on it, but it's just max, middle, min, middle, max, middle. That's all you're doing. So every scale factor, I'm moving. See this? Look how easy I can graph. And yes, I'm going to draw points every single time because it's kind of tricky to draw trig without points. Almost done. And I'm going to end on 360. And now I can graph my sine function. Okay, you can also notice from 0 to 360, there's 1, 2, 3, 4 cycles, right? That's what this 4 represented. But we didn't really care about that, right? Because we did it this way. So if you scale it properly and you just go every scale factor is your next point, it's super easy, right? You probably got confused just with the scale, and that's fine. That's the hardest part. So like max energy over here, because the rest is easy. If you didn't understand the rest, trust me, it'll come, because it just, every box is the next point. If this was a cos function, we start at the max, and every box we go, that's it, next point, until the question says to stop. Okay, let's do a little bit more difficult one. Okay, we're gonna amp up the difficulty on this one. We have every single letter. We have negatives, big disaster, but it's not gonna be a big deal. This notation over here just means that I'm graphing it between 0 and 360. That should be a bit of a nicer degree sign. Okay, just like in the other question, it says from 0 to 360. This is the proper set notation to represent x can only be 0 to 360. Okay, so let's do everything the same that we did before. We're gonna start with the y values and we're gonna draw our horizontal dotted lines. The first one that I draw is always my c value at -1. So if I call this -1, I draw a dotted line at -1 like that. And the best way to think about this is use the amplitude from the c. It's not about math. If you put an equation in, you might screw up because there's negatives. But just think, if you're at -1 and the amplitude is -2, it doesn't matter. That just means it starts down instead of up. It's still 2 because amplitude is absolute. It's just positive. I have to go up 2, so I'm going up to +1. That's my max. And I have to go down 2 to -3, and that's my min. So in 5 seconds, I just graphed the dotted lines where I have to draw all my dots. Every single dot is only drawn on these 3 dotted lines. In the middle, the max, the middle, the min. The middle, the max, the middle, the min. Okay. Now we have to focus our attention on our scale. I gotta find the period for the scale. The period is 360 over k. So the period is 120. That's my period. My scale is this divided by 4. 30 degrees. So I have to go to 360. I have to graph in 30s. 30, 60, 90. So 30. So I don't have to draw this 30. See how tight these are? If I draw 30, 60, 90, it's going to be ugly. So why do that? I could just write down every other one because it's inferred that that's a 30. So I'm just going to do this one. Keep going. Plus 30 is 150, not writing that. Plus 30 is 180. Plus 30 is 210. Plus 30 is 240. Plus 30 is 270. Plus 30 is 300. Plus 30 is 330. Plus 30 is 360. Boom, and I got to my 360. But I need that 30. Like every box on your grid needs to be a 30 because I got to move in 30s. So if a box isn't 30, I have to move in not a box. And it's really quick to move in boxes. Yeah, I hope that makes sense. Okay, and believe it or not, I'm done. That's crazy that this is how easy it is. So now to graph, I have to graph a negative sine function. Okay, that's new, but that's no big deal. And we have to start 30 degrees to the left. Okay, no problem. I can go another 30 to the left. -30. So I'm not starting on the 0 anymore. I always start on the c value. So this is what the x-axis was in the previous question. Sine would start here if there was no shift, but it's starting here because there's a shift. 30 to the left. This is negative sine, so instead of starting in the middle and going up, negative sine starts going down. So that's maybe a confusing thing here, but I mean, there's only 4 options. There's sine, there's negative sine. There's cos, there's negative cos. One starts up, one starts down. It's really easy. So now to graph, every box, I put my next point. Down, here, up here, down here. You might be tempted to plot it on here, but that's wrong. You're only plotting it on your dotted lines. 120 is down here. And then I have every box, I'm going to the next dotted line. Look at that, how easy this is. Done, I got the 360. Take out your artistic ability. Find yourself. Look how beautiful that is. I can put an arrow there if I want. There's arguments there whether I should put an arrow because this is like ends there. It also doesn't say to graph in the negative. So if you want to be a little extra, you could be like, well, I'm just going to erase this now. Right? It's easier to erase it than to understand where it starts. Because my whole shortcut in graphing this is just if you know where it starts, just graph it from there. It's really easy because we know where sine starts, we know where cos starts. Okay? Cos starts at the max, so I would start on the max. Negative cos starts at the min, so I would start in the min. Sine starts in the middle and then goes up. Negative sine starts in the middle, then goes down. Easy. As long as you have your scale, this is the most beautiful way to graph that doesn't require any effort, doesn't require a calculator, doesn't require anything really. Use some color so it looks pretty. Put arrows if you want because they do go forever, although this says it doesn't, but I'll leave that up to you. And that's it for graphing transformations of sine and cosine. You want to just quickly do a cos. Let's say this said cos. And let's say this said minus 30, just to see the difference. So this just means nothing else changed in my -2, my 1, my period. Cos is here, it's negative. And it's shifting 30 to the right now. So where does negative cos start? Well, negative cos starts on the minimum value on this red line. Shifted 30 to the right, well, I got to start it right here. That's the minimum, shifted 30 to the right. That's the only change that is now happening. So to graph this function, y equals -2 cos of 3x plus 30 minus 1, I've only made that adjustment, that's it. Next point goes here, next point goes here, next point goes here, next point goes here. That's it. Keep going. See how annoying this would be if I didn't have the dotted lines? I'd have to keep verifying that I'm on the right track over here by looking left and right. All this looking left and right, waste of time. Middle, bottom, middle, top, middle. Oh, I have to start at 0. Just go back 1, back to the middle. That's it. Graph your cosine function. And the orange one is this equation. That's it. Super easy. Trig is amazing if you just give it a chance. Don't make these graphs when you look at them intimidate you. They're fairly easy to come up with. Okay, and you need to know how to visualize them this quickly, so when you have a word problem that's complicated, that visualization is going to really help you solve those word problems.